Granulated slag is also used in glass manufacture as a source of alumina and silica. And good news for workers, laboratory tests by New South Wales government scientists have shown that granulated slag is suitable for grit blasting, whereas silica, present in natural sand, is hazardous to grit blasting operators' health.
Well, Workcover received in this laboratory a sample of granulated blast furnace slag, and we performed a X-ray diffraction analysis on the sample, and we were not able to detect any crystalline forms of silica. We were not able to detect any of the harmful forms of silica in actual fact.
Granulated slag is particularly suitable on soft metals, such as aluminium, where a light etch is required. Granulated slag, like all other slags, is an ideal soil conditioner where its lime content is beneficial to acidic soils. Slag has also attracted the attention of Australia's leading scientific research organisation, the CSIRO. After years of rigorous testing, the results are excellent.
We have had a look at road pavements. We have had a look at road pavements that have been built about 20 years ago, perhaps some of the first that were built in Australia using slag concretes. And we've certainly found that with heavy traffic conditions, the slag concrete pavements do come up well in terms of the wear and durability.
The next step in the iron and steel process is producing steel by reducing the carbon content of iron. The most common steel making method used in Australia is the basic oxygen steel process, or BOS. This involves placing about 50 tonnes of steel scrap in an open-topped vessel and adding about 200 tonnes of molten iron brought directly from the blast furnace. A liquid oxygen lance is lowered into the vessel and a violent reaction takes place. Lime is added to form a protective slag. On completion of the reaction, the steel is drained into a ladle, with the slag being poured into a second ladle. Another excellent construction material has been created: steel slag. Throughout Australasia, modern handling equipment is used to move the slag from the furnace. These 9-metre wide pot carriers, costing more than $1 million each, have a lifting capacity of 150 tonnes. The slag is poured into ground bays where, after initial solidification, it is cooled with water sprays. Steel slag is a well-shaped, tough and durable material. Its uses are again many and varied. The advantages offered by its low free lime content have been recognised and utilised in heavy-duty pavements as a stabilising agent. In Newcastle, the Port Corporation required a heavy vehicle bypass road around the suburb of Carrington. Due to the tidal nature in this area, a heavy-duty pavement was needed to withstand the constant wetting and submerging of base courses. Steel slag pavement's durability was well suited to such extreme conditions. Mount Ousley, a busy road leading in and out of one of Australia's largest industrial cities. Steel slag has been used in the construction of a lane leading to a truck arrestor bed in an area renowned for its difficult subgrades and fatal truck accidents. This road base, made totally of slag, required no additional binders, resulting in a very economic and efficient product. The ability of tyres to obtain adequate grip on road surfaces, especially in wet conditions, is an important factor of road safety. Steel slag has superior skid resistance compared to basalt, and its unique characteristic make it an ideal aggregate for asphaltic concrete. As a tough and durable material, steel slag rail ballast has been used for the rail network within BHP steel complexes. Sections of the Port Kembla coal loader complex have also utilised steel slag rail ballast. One very important aspect of the use of slag we have so far neglected to mention: its contribution to the environment. With the world facing an ever-increasing shortage of natural resources, we must take every opportunity to conserve these materials. Surely it's preferable to utilise co-products such as slag rather than to keep enlarging unsightly holes in our landscapes. The use of slag products also enables the conservation of energy already expended to generate slag during the iron and steel making process. The use of slag in cement manufacture substantially reduces the generation of greenhouse gases. Certainly worthwhile thinking about when considering our future. If this valuable product is not utilised, slag has to compete with other materials for landfill space or create unsightly stockpiles.
I look upon a slag operation as being something very special. Just think about it. You come in each morning to the slag bays, they're full of material. You take the slag out to the crushing and screening plants where it's processed. You come back in next morning, the bays are full again. Truly a magic quarry. Well, what a wonderful way to conserve natural resources for future generations.
As we enter the new millennium, the Australasian Slag Association and its member companies will continue to further investigate and develop new opportunities for this valuable product. Through embracing responsible and environmentally aware business practices which benefit the whole community, slag can claim to be Australia's largest renewable resource industry, saving energy, preserving the environment and conserving natural resources. Actually, when you come to think about it, is there really any other choice? If you would like further information or copies of technical guides produced by the Australasian Slag Association and its member companies, please contact us via our website www.asa-inc.org.au or by forwarding email to uslag@asa-inc.org.au.